I'll be showing you how definitions are a lifesaver, because if you're given a question that you don't necessarily know how to complete the steps, if you know the definition, you should be good to go. So let's say that we're asked to find a coordinate vector x relative to a basis b, and we don't know how to do that, but we do know the definition. So what is the definition? It is more or less the weights C1 all the way up to CP, such that x equals C1 B1 to CP BP. So the coordinate vector x relative to b is going to look like this, with those being the weights. We are also pretty familiar with the fact that an equation that looks similar to this is this one. And we know that this equation relates to ax equals b, which we are pretty familiar with solving and multiplying before we even got to relative x's to bases or anything like that. So if we know all this and we know the definition, then we're good to go. So if we have a matrix that's multiplied by a weight, we have a matrix that's multiplied by a weight. I did that really backwards, sorry. And then back to this coordinate vector, we have a matrix, these b's, multiplied by a weight. Good. We know what to do with matrices that are multiplied by weights. So let's say that we're given, so we're dealing with this right now. Let me underline that. We're given the b1 and the b2. b1 is equal to 1, negative 4. b2 is equal to 2, negative 3. We're also given what the matrix and the weights are equal to, which is x. Over here we have a matrix and the weights are equal to this b. We know how to solve for this b. We know how to solve for the weights that give us this b. We have a matrix, we have a quote-unquote b, or what goes on the other side of the equal sign. So we can move on from there. So let's make this be our matrix. We need weights. And again, this matrix and these weights are going to give us something, which is going to be this x here. So this x here is the 1, negative 6. And if you can remember, the way to solve for weights, or the way to solve for this x that we have done many times before, is to make this look like an augmented matrix. So let's do that. Okay. Now we're going to solve this augmented matrix, which will give us the weights that we're looking for. It will give us the C1 and C2, this C1, these weights. That's what we need. So I need this to be a 4, so that I can have a positive 4 and negative 4, which will give me a 0. So I'm going to multiply this entire first row by 4. I'm going to add this first row to the second row. So I'm going to take 4 times 1, which is 4, plus a negative 4, gives us 0. 4 times 8, 4 times 2 gives us 8, minus 3 is 5. It's supposed to be a negative 1. My bad. 4 times negative 1 gives you negative 4. Negative 4, negative 6 gives you negative 10. All right. Now, let's we can simplify this by, well, we want this to be a 1. We want all of our leading terms, not leading terms, we want all of our pivots to be a 1 for this to be in reduced echelon form. So how are we going to get this to be a 1? I'm going to divide by 5. So I'll leave this the way it is. Divide by 5, get 1, and then negative 2. Although this is in echelon form, it needs to be in reduced echelon form, which means that there needs to be a 0 above and below all of our pivots. So here's a pivot that does not have a 0 above it, so I need to make this be a negative 2, because negative 2 and positive 2 gives us 0. Great. And now we are finally in our reduced echelon form, which is what we want. And our weights are going to be, C1 is going to be equal to 3, C2 is equal to negative 2, and this is our x coordinate vector relative to this basis B that we were given.